right. Well, thank you so much, Crystal. I really appreciate you inviting me to give this live webinar today. Thank you for all of you who are taking some time out of your day. I know there's a lot of other things that you guys would love to be doing, especially billable hours. Everybody's super busy right now. But just wanted to share with you this presentation that we've developed. It's a fairly newer one that I'm bringing to the region. It's the first time I'll be delivering it out to everybody today. So I hope everybody enjoys it. It's not as exciting as, say, learning about cross-laminated timber or anything like that. But I think those who are very serious and interested about light frame construction and how to deal with shaft walls and some of those requirements, I think you'll find this very interesting. And so I'll just go ahead and dive in. So before I actually do jump into the whole shaft wall solutions, for those of you who haven't heard me present before or are not familiar with WoodWorks, we are a nonprofit organization. And myself, I have about 10 years of design experience as a structural engineer. I've been working with WoodWorks now for 9 years, working all across Florida, Alabama, and Louisiana, working with the whole entire AEC community. And the WoodWorks goal here is to kind of meet you where you are. We understand that wood frame design, be it light frame, heavy timber, mass timber, even a hybrid type system, those are kind of like unicorns at times. They're a little unique in themselves. And so we're here to navigate the codes with you, provide support in terms of figuring out fire resistance ratings, acoustical assemblies, construction types, working with the building officials, connecting you with people in industry. So we're just here to kind of provide all of those services to you. And so, as I mentioned, we are a free organization. We are a nonprofit. We're funded by the Softwood Lumber Board, the U.S. Department of Agriculture, and Forestry Innovation Investments. We also have some sustaining partners in industry, as well as market development partners, industry advantage partners, and some channel partners. And so what WoodWorks would ask is that if you find value in the information that we deliver to you, if you're interested in working on some type of a light frame project or any type of heavy timber or mass timber project, these are the members that support our organization. We would encourage you to reach out and connect with those, and we can connect you as well. Check out woodworks.org, our landing page. You just go right in here and you can ask us questions. If you need some type of a project support or assistance, you can go in there, put in your zip code, and it'll direct you exactly to the individual that you need to connect with. As you can see, we are a nationwide organization. We have regional directors scattered all throughout the country. We do have some available positions that are open. You could always check out the WoodWorks website and check out what positions are available if you're interested. This is the AIA approved presentation. We are an approved provider. G516 is our membership number there, our provider number. And then in terms of course descriptions, I know I try not to read verbatim from the slide because honestly, you don't need to sit here and listen to a presentation if I'm just reading verbatim. But in summary, we're going to be reviewing things like elevator shafts, stair and mechanical shafts. We'll review some of the relevant code provisions, and we will also cover some fire resistance rated design parameters, as well as some architectural and structural considerations as it relates to shaft walls. So once again, some of the learning objectives, we're going to review fire resistance rated code provisions that are relevant to the wood wall or the wood shaft wall design. We'll introduce some assemblies and kind of look at their applicability in terms of elevator stairs and mechanical shafts. We'll provide some detailing options. And then, not to get too deep into the structural design side of things, but just kind of touching on some topics that make you kind of aware some of those structural design considerations that as you're laying out a building or you're incorporating different materials into your structure or your building, that you're just aware of some of the implications of doing that. All right, so this presentation follows an outline and is based on our shaft wall solutions paper. And so this document, it will be helpful for you as kind of an additional resource after this presentation. You'll literally be able to kind of follow that document, go through. If you want a deeper understanding of a particular topic, this presentation is kind of built off of that paper. We worked on them both kind of hand in hand, side by side. So if there's something that you don't quite understand, or maybe I wasn't clear enough in explaining it to you, this paper is a free download, so it would allow you to just kind of walk through this presentation and get a deeper dive into some shaft wall solutions for light frame and mass timber buildings. All right, so before we jump into the meat of this presentation, here's kind of this collection of shaft walls we may be seeing on any particular project, right? Sometimes we see wood shaft walls. Sometimes we may even see something like a masonry or even a light gauge steel shaft wall. So those are items that we can look at as well. And so if I was giving this presentation, say live or in person to you, I do my best to try to really interact with the crowd, ask some questions, get some interaction from you. Probably like something like, say what are shaft walls? Why are they so important? Why are they such an important part of, say, a multi-story structure? But since we're in this virtual world, right, we'll have some Q&A here. I'll answer those at the tail end of this. Because this is the first time I'm delivering this presentation, I want to be sensitive of everybody's time. I'll answer as many of those questions at the end of the presentation that I can. Typically, some of these shaft wall questions get pretty wonky and kind of go down a rabbit hole. And so if I don't have the answer for you, I'll dig into the code, find it, and get back to you. But if I don't get to your question, Crystal's assured me she'll get those questions over to me and I'll get them answered for you as soon as possible. So the intent really is shaft wall really is the intent is to kind of form this enclosure, right? So when we have something like stair towers, plumbing or water lines, or even a ductwork system, right? We must have some type of a vertical opening or a chase or something like that to confine from any fire, smoke, or any type of a hot gas if a fire was to occur. And that's why shafts are so important. They help us confine fires, and they do not allow those fires to pass through any adjacent levels. And so there are three main types of shafts we will see in, say, our standard multi-story building. So we have our elevator shafts, we have our stair shafts, and we have our mechanical shafts. Now, the code doesn't really differ in, say, the requirements for these three types that I just mentioned. There are a few specific requirements for exit stairways, for those exit stairway shafts. But for the most part, all of the code requirements I will cover, those really will apply to any type of a shaft enclosure or a shaft wall, regardless of what's inside that shaft wall. So because giving you this kind of summary and learning objectives at the beginning of the presentation, really wasn't enough, here's kind of the agenda of these kind of 10 items that I'm going to cover today. And while this agenda may look very long and you're thinking to yourself, how are we going to cover this in an hour? A lot of those are very brief points, and I do hope that I can get all this in an hour. So much of what we will be discussing is really the result of questions that we've received in the past from, say, architects, engineers, and maybe even some building officials. So my goal is to hit on those common issues as it would relate to wood being accepted for shaft wall construction. And as I mentioned, some of these will be super quick, with the exception probably number 8. That will be somewhat of a fairly longer point of the discussion today. So it's important to take a step back and understand that here I have 4 different types of fire resistance rated walls that are shown on this slide. So I have exterior walls, fire barriers, and fire partitions. So while some of these sound very, very similar to each other, it's very important that we understand how the code defines shaft wall requirements and to understand where shaft walls fit in these 4 different wall types, so that we can appropriately apply the conditions for that particular wall. So let's jump into our code requirements, like super fun, exciting stuff, right? There's a lot of code in here. And so that's why I say that paper is great to go back. I understand, like, being a design engineer for almost 10 years, sometimes you're sitting in these seminars and your eyes, they start glazing over because there's all these code sections. So I'm aware of that, but I want to make sure that you have these code sections in front of you, and then you can go back and reference them when you need to look at them. So IBC section 713, that's really the section that discusses our shaft enclosures. And so again, our shaft walls are just there to provide that shaft enclosure. So in section 713.2, it states that shaft walls shall be constructed as fire barriers. So remember the 4 different wall types on the previous slide. A fire barrier was one of those 4 different wall types. So this is a very important distinction to understand. Shaft walls are fire barriers, and they must be constructed as fire barriers. And so section 707 covers fire barriers, and we'll spend some time jumping back and forth between section 713, which deals with the shaft enclosures, and then section 707, which deals with fire barriers, because a large portion of the provisions for shaft walls, those come directly from section 707, that fire barrier section. So if you're starting to feel overwhelmed when you're working on a shaft wall situation, just take a step back, take a deep breath and go, okay, really at the end of the day, I have a fire barrier and I know the requirements for fire barriers. And so I would say 90% of the time, you're going to be able to default to that section 707 and get your answer if you're confused about a particular section for your shaft wall. So one of the key design components to understand about shaft enclosures is their required hourly rating. And so a quick summary here is that shaft walls must be rated for 2 hours when they are connecting 4 stories or more. And when that shaft enclosure is connecting less than 4 stories, we can specify a 1 hour rating. So if our building has a basement, we do not have to include that in the number of stories that are connected. And that's assuming that the shaft enclosure is also extending down to that basement. If we have a mezzanine, we don't have to include that as a story in terms of how many stories we're connecting either. Perhaps one of the biggest hurdles we currently see is that many people don't even realize that wood can be used to build shaft walls. So to validate this to validate this case, we can look to section 707.2 that states that shaft walls shall be built from any material that is permitted by that particular construction type. And so since construction types, say 3, 4, and 5 can be framed completely out of wood, with that said, that means that our fire barriers are also, AKA our shaft walls, can be formed with wood as well. So in construction types 1 and 2, though, section 603.1 will allow the use of fire retardant treated wood for non-bearing partition walls when the fire resistance rating is 2 hours or less. Well, the code doesn't really specifically call out shaft walls. There may be a discussion to have with your local AHJ if you're working on, say, a 4 or a 5-story light frame building on a podium, and you would like to use like a light frame shaft wall for your podium structure. So this may be a conversation that you could have. Sometimes we'll get questions where we have that type 1 podium structure. Can that shaft wall extend down into that podium and be light frame construction, or do I have to build that first story shaft, if you will, out of masonry? And so there is a conversation to be had there. And the 2018 IBC has made some changes to clean that language up to be very direct in that you are allowed to do that. All right. Since we've acknowledged that construction types 3, 4, and 5 can have their shaft walls framed completely in wood, I want to do kind of a brief recap of the, say, following construction types. So type 3 construction allows all interior elements, so your walls, floors, and roofs, to be of standard light frame wood construction. And in addition, all of your exterior walls can still be of light frame wood construction as well, but they must use FRT or fire retardant treated wood for those exterior walls. In type 4 construction, all interior members can be of heavy or mass timber elements that meet the minimum size requirements that are defined in section 602 of the Florida Building Code, or the IBC. In addition, all of your interior partition walls, those can be framed of light frame construction if they have a minimum of a 1 hour fire resistance rating. And lastly, the exterior walls of type 4 construction can be built from fire retardant treated wood, similar like we do in type 3 construction, or they can be built with CLT, and then you would have to install a layer of FRT sheathing on the exterior face of the panel. And then finally, type 5 construction, that's the fun one where really anything, that entire structure can be framed completely out of wood. Oh, my transition isn't working here. Come on. All right. So inside, here's a quick little summary. So construction types 3 and 5 will allow standard light frame interior shaft walls, and type 4 construction will allow either a heavy timber or a light frame wood construction, as long as it has a minimum of a 1 hour fire resistance rating. And so for exterior shaft walls in type 3 and 4 construction, we can use FRT framing. Also in type 4 construction, we can use CLT. And lastly, in type 5 construction, we can use standard light frame wood construction throughout. So just kind of a quick summary there for you. All right, so what are some of the reasons we may consider going to a wood frame shaft wall? And so cost can definitely be one of the reasons that you may want to consider utilizing a light frame shaft wall. Light frame shaft walls have proven to save material and labor costs, so that's always a good plus. As would relate to the construction schedule, light frame shaft walls can shave even weeks off of your typical construction schedule. If you think about your masonry shaft walls, they need to be constructed prior to the framing stage. So this can add several weeks to your project schedule. And so if your framing crew is framing and installing all of your interior walls, your floor framing, your roof framing, all of your exterior walls, why not just have them go ahead and frame up your shaft walls as well? Differential movement is a design consideration that you simply cannot ignore. You cannot neglect this. You definitely will have differential movement between, say, a masonry wall and a light frame wood structure. So a multi-story wood building, it definitely will shrink, and the masonry will not. And so you need to make sure that you account for this. I'll actually be giving a presentation in person at the AIA Florida trade show on the morning of July 30th, and that will be accommodating shrinkage in multi-story wood frame structures. And so be sure to attend that class in person if you're going to be there. I'll take a deeper dive into that, and that will be kind of like a great part 2 to understanding shaft walls as we get into how the buildings behave in terms of shrinkage. So really a great presentation to see. So on the previous slide, I mentioned a kind of a cost and schedule savings. And so there's a good potential there for converting, say, masonry shaft walls to light frame shaft walls. And so this was a case study here where a project had 5 different shaft walls. It was a 4-story project. They were originally designed as masonry shaft walls, but they were really coming in over budget on this project. And so the design team knew they needed to reduce the cost somehow, and they decided to take a look at and maybe even consider light frame shaft walls. And so this exercise really turned out in their favor. It was a massive success. They were able to reduce the cost by over 50%. They shaved about $176,000 off the cost of all of the shaft walls. And so not only did they reduce that hard cost, but they also were able to shave about 3 weeks off their construction schedule. And so this was really a great win for the overall project and the teams involved. So a really great case study there. Another option we're starting to see in not only mass timber buildings, but light frame buildings as well, are mass timber or CLT shaft walls. So this is another great alternative to, say, a masonry shaft wall system. And these can actually be erected in hours versus, say, several weeks to get a whole entire masonry shaft wall system in place. So when you consider a mass timber shaft wall system, you really aren't able to take, say, this apples to apples approach here. And this is kind of tough because as a design community, right, we're all starting to learn about this mass timber system. We have decades of knowledge, information, and costing data on masonry, concrete, and steel, but we're still working through getting all that costing data in place for mass timber. And so the thing you have to remember is when you're approaching a mass timber system or even a project in itself, you really should review the entire system holistically to determine, say, what your overall cost savings is going to be. And so when I say holistically, let me explain this a little bit more for you. So this image on the right, this is the Candlewood Suites Hotel. This is located at the Redstone Arsenal Army Post, and this is up in Huntsville, Alabama. This project was completed back in 2015 by Lend-Lease. And so we also have a very good case study on our website that complements this project. But in summary, to give you a quick summary, these walls are very similar to, say, like your tilt panel type construction. There are 3, in this particular project, there were 3 4-story shaft walls, and they were erected over the course of 3 days. So let that sink in for a second. The first shaft wall that they did, 4-story shaft wall, went up in about 13 hours. Now, this was a crew that had never worked with mass timber before either. In fact, the contractor hired, because it was difficult to get qualified labor on a military post, an Army post, they actually hired veterans and trained them to work on this project. So we're talking about teams that had just very little training when they started working on this project. So the first shaft wall went up in about 13 hours. The second one went up, I think it was about between 9 and 11 hours. I couldn't find the hard point on that one, but I knew it was somewhere in the middle there. And then the final shaft was completed in 7 hours. And so, like I said, this was their first attempt at CLT at a CLT building, and they obviously increased their speed of construction as they became more familiar with this material. And so when considering what your overall cost savings would be, you really have to consider a couple of things. Like you need to consider the speed of construction and any potential savings that you're going to get for removing weeks off your construction schedule. In addition, you may need to consider eliminating the cost of interior finishes that may be associated with labor. And finally, these are tested assemblies. So they're not only working as your structure, they're giving you visual appearance and benefit from an architectural standpoint. So you're eliminating those finishes. You're not paying for labor and materials to come in and hang sheetrock, get screw inspections, tape and mud joints, texture, paint, all that goes away. So those are line items that you can start to move away as you're looking at the holistic cost savings of this. And so there are tested assemblies for up to 2 hours for these shaft wall systems. So there's options out there. You're not chasing some magical unicorn. We can really help you get those dialed in on your projects if that's interesting to you. And so I think this is a very important point to drive home. There is no restriction on using wood for shaft wall construction at all for construction types 3, 4, and 5. Don't get caught into thinking these are fire walls. Remember, so we can use this in construction types 3, 4, and 5. Remember, just because it's a shaft wall doesn't mean that it needs to be non-combustible material. So now that we have all of that kind of behind us, let's talk about continuity for our shaft walls. That's always a big question that comes up. So if you look at section 713.5 for shaft walls, it simply points you to the continuity requirements for fire barriers. Remember, I said, if you start getting in a logic circle or you're confused, you just start looking at what your requirements are for fire barriers. And this states that fire barriers shall extend from the top of the foundation of the floor or ceiling below to the underside of the sheathing and shall be securely attached to it. And so this also must be continuous through any type of interstitial space or concealed space. So let's see here. So the next slide here is you might be considering or asking yourself, so what do these continuity provisions look like? So here's an image that's directly from the code commentary. You can see the wood frame construction on the right. The fire barrier is extending up to the top from our foundation and slab all the way up through the interstitial space. And so you can see right to the underside of the decking. So that's very straightforward in terms of what our fire barrier requirements are, similar to our shaft walls in terms of continuity. And this image you can see, they made it very simple, right? Like the most easiest scenario here, all that floor framing is running parallel to the shaft wall, right? So, in a few moments, I'll kind of touch on some of what the alternatives would look like when you have your framing running perpendicular to your shaft wall. So it's like, it's like the textbooks in school, you get the best case scenario, but in the real world of practice, you never run into any of those design examples. So we want to make sure that we have something in place for you. So in the field, what does it look like in the field here? This is what we're going to look like if you haven't really had a lot of experience with light frame shaft walls. We're just going to run those studs all the way up tight to the underside of the plates. The plates are going to go right up to the underside of the sheathing. And that's our continuity requirement for shaft walls. Pretty straightforward and clean, just like you would see in fire barriers. The other aspect of fire barriers and shaft walls that often comes up in question for us is that supporting construction requirement. So section 705.1 states that, supporting construction for a fire barrier shall have the same fire resistance rating as the fire barrier itself. So if you have some type of a 2-hour fire barrier, it doesn't go all the way down to the foundation for some reason. And the beams and columns that are supporting that fire barrier, well, those must be rated for 2 hours as well to match that entire rating for that fire barrier or shaft wall in this situation. Another point that has come up on shaft wall construction is that of the joints. So joints and voids, that's always kind of a question. So joints at intersections in a fire barrier, those must comply with section 707.8. And what that says is when fire barriers intersect the underside of a fire resistance rated floor or roof sheathing, we must comply with 715. So if you think about the field image we just saw, where we have that wood frame wall coming up and butting up to the underside of our floor sheathing, do you think that's considered a joint? And so what we need to we need to make sure that we're meeting the requirements of section 715. And really in standard wood frame construction, that would not be considered a joint because it's butted up tightly and it's attached to the underside of that floor sheathing. So if we're looking at, say, this example here, we look at the definition as to what a joint is, we can validate that we don't need to meet that requirement of section 715. The code defines a joint as a gap that is usually there to allow some type of a movement, some type of independent movement between the two building systems or two elements caused, say, by thermal, seismic, or wind, or any other type of a loading. So if we're talking about standard wood frame construction, where our walls are going to come up and be tight up against the underside of the floor, then that does not need to be treated as a joint, and we would not need to comply with section 715 for that condition, because it's not any type of an expansion joint or anything like that. It's a tight fitting up underneath the decking. All right. So just in summary, if our wall is in direct contact with and securely attached to the underside of the floor, that is not a joint. We do not need to comply with those sections 715. All right, let's talk about penetrations through our shaft walls. One of the other areas that building officials start to get concerned about are penetrations in our shaft walls. And section 713.8 specifically addresses those structural penetrations of our shaft walls. And so this section states that structural elements can, so we're allowed to penetrate that shaft enclosure if they comply with section 714. And we also see a very similar provision in section 707. Both of these sections point to 714 in the FBC, right? Everything comes back to shaft wall compliance being that of what we need to do for fire barriers. So typically shaft wall penetrations may occur in one or two areas. So if you look at the image on the left, you could have, say, your standard floor construction that may be the entire depth of the floor, or like this picture shows, just maybe the top chord, if you will, kind of bearing in this wall here. And that could be considered a structural penetration of the shaft wall once that gypsum wall board is installed and notched up around that top chord. That membrane will go all the way up, fit tight to the underside of the floor sheathing. If you're looking at it, say, from the inside of the shaft wall, you may have something like, say, your landing beam that may need to penetrate the shaft wall to support your stair framing or something like that that's coming up. So again, the result is that our gypsum wall board or our membrane is going to have to be notched around these members, and the code will allow us to have these structural penetrations. As we saw on that previous slide, right, the code specifically says that we can have these penetrations of our shaft walls if they comply with that section 714. And 714, that really provides us with two options for penetrations in our shaft walls. The first option would be to use some type of a fire tested assembly, but we're not really going to find any testing on wood structural penetrations, if you will, for fire resistance rated assemblies. It's just not available. So at this point, the option that we need to look at is using some type of a fire stopping system that's been tested in accordance with the ASTM E814 requirement. So looking at this in terms of a fire stopping system, you're probably very familiar with these fire stopping systems. They usually include some type of a fire caulk, but the whole fire stopping system really needs to be considered, not just the fire caulk. We may be familiar with a lot of these because we've seen them used for our plumbing lines or our ductwork, passing through a rated wall or some type of a floor assembly, something like that. All right, then we could turn to doing the same thing from the inside. If we're running our landing beam across and through that shaft wall here, we can do that with some type of our fire stopping system installed, which would have to be installed after the fact. So one question you may have as well is, where do I find these fire stopping systems? And there are a few options. We'll see on the next slide for pre-tested assemblies that include these wood structural penetrations. It really really, the one I'll share with you, there's really one that I would promote here and say most manufacturers that have these fire stopping systems, they're going to be able to provide you with some type of an engineering judgment detail that will basically say, for your specific project, for your specific condition and your specific detail, use this particular product of ours. And then we're going to give you the parameters and the requirements for installation. You're going to install it in accordance with this, sequence of events. And that will be equivalent to that of an ASTM E14 fire stopping system with, say, an F rating of up to 2 hours. And so like the detail you see here on the right, this is one from Hilti. This is a service that the fire stopping manufacturers can definitely provide for you. So if you're in a pickle or you need something kind of unique, I would encourage you to reach out to your fire stopping manufacturers, and they can provide these engineering judgment details. Or you could always hire a fire engineer or something like that. So those are some of the options, and they can do that for you as well. So again, just to highlight, structural members are specifically called out in the FBC. We can penetrate shaft walls with them, and that typically means we're providing that fire stopping system, some type of fire stopping system. So let's not forget that we often have shaft walls that are also part of our exterior wall systems as well in our building. And so this is common, say, in our large multifamily construction type buildings where we have, say, an elevator shaft in the core or in the middle of the building, but often our stair wall, our stair towers, or our stair shafts, those are often pushed out to the ends of the building. So, or at least around the perimeter of the building. And so let's take a look at some of these unique provisions that we may see as well. I'm just going to take a drink if you bear with me one moment. Going back to the shaft wall enclosure section of the code, it states that 713.6, when the exterior walls are part of a shaft enclosure, those walls actually comply with the code provisions for exterior walls and not for shaft enclosures. So there is one exception to that, as you can see here, and really that's really the one that is really worth highlighting. That's in section 1023.7 for interior exit stairways. I'll talk about that in just a moment. But basically what that's saying is that if we have an exterior wall and it's also part of a shaft wall, we're going to just have to meet the requirements for that exterior wall, right? We're not have to meet the requirements for that shaft wall. And this question becomes, where do we find those requirements, Jeff? Where are we going to look for those requirements in the FBC or the IBC? And so it's one of those things, once you see it, you have the aha moment. So all you really need to do is go and look at table 601 of the FBC. And so if we have a bearing wall, that's an exterior shaft wall, you can see here that the rating for that wall will either be 2 hours, 1 hour, or maybe in some unique cases, if you're in like a 5B situation, you have a 0 hour rated exterior bearing wall. So pretty straightforward. Once again, I like using the term unicorn because sometimes we get caught in these circles, these logic circles. It's pretty straightforward when we're pointed in the right direction. Now, if you're looking at some type of a non-bearing exterior shaft wall, where do I go? And so table 601 will direct you to table 602. And this will tell you what your hourly rating for that particular wall needs to be as a function of your construction type and your fire separation distance for that exterior wall. Not going to jump into conversations about, fire separation distance today, just trying to help you navigate in terms of where you would go to find that rating for your exterior shaft wall in a non-load bearing situation. So this one's kind of meaty here, and I'll do my best. I can't stand personally slides that have a lot of text on it, but once again, this is something that you can go back and read and digest on your own. But a few slides ago, I did mention that section 1023.7 was worth pointing out, and so that section states that if we have a standard exterior wall construction, and it's not at the shaft, and it's non-rated, or if we have a portion of that wall that has unprotected openings, and that would extend over and would continue into that shaft area. If that's the case, if that section of the wall is exposed to the shaft section as well, by an angle of less than 180 degrees, we must rate that section of the exterior wall beyond that shaft for a minimum of 10 feet. So now you're going, what the heck does all this text data mean here? So I've got some images that I'm going to share with you. So basically the idea behind this is that if we don't want a fire to be able to jump from the main portion of the building, through that non-rated exterior wall and then get over into our shaft enclosure, this is what we're going to have to do. So there's 3 options. And once you see the pictures, I'm a picture kind of guy myself. So once you see the pictures, things start to make a little bit more sense for you. So let's take everything that I just mumbo jumboed there, and you're trying to decipher. Let's take everything I just mentioned and look at how this would apply to 3 different scenarios here. And let's say this is our shaft enclosure, right? We have our exterior wall of the building that makes a 90-degree turn and extends down. So remember, if that shaft exterior wall is exposed to other exterior walls that are non-rated by an angle of less than 180 degrees, right, that wall must be rated. And so here we are. We're in the scenario where we have an angle of 90 degrees, which is obviously less than 180 degrees. And so in this scenario, we must rate that portion of the wall, which otherwise didn't necessarily need to have a fire resistance rating, for a minimum of 10 feet from that shaft, because it's intersecting there at an angle less than 180 degrees. So all of that verbiage that we saw on that previous slide, hopefully that starts to make sense. Condition 2, we didn't have to do anything because we have an angle of over 180 degrees where that wall continues past the shaft, right? So like we see in here, we have that separation of 180 degrees or greater, and that's what our minimum requirement would have been. So we don't really have to do anything here. Again, this is only assuming that they didn't already require some type of a fire resistance rating in condition 2. Condition 3, similar scenario. If you look the exterior versus the interior portion of the building, same thing would be true here for condition 3 as well. Both sections of the wall do not need a special rating because we have this 180-degree separation at both ends of the shaft wall. All right, now let's look at some of the structural considerations for shaft walls that are also, say, an exterior wall. I'm going to look at a few different areas of our stair shaft walls, and we're going to highlight a few of those areas to be aware of. You can see on the upper left, that's our normal landing where we have our floor system or our landing tying in to our shaft wall. We have, maybe our landing at the bottom, those 2 areas that we're using, maybe a ledger, some sort of a hanger, if you will, to attach our joists at the landing, at the floor landing. And then in the upper right there, you see where we have this potential hinge point that's been created in our shaft wall. And so how do we handle that? And is that a good idea or a bad idea? And so let's jump into a couple of these items. So the reason there are some, say, constructional considerations that we need to be aware of as would relate to, say, our standard exterior wall construction, we really need to look at something like this where we have, say, wind or a seismic loads, that those are acting in a lateral fashion or horizontally on that exterior wall, right? So we know that those studs in a multi-story building usually do not continue from the foundation all the way up to the roof. That's just unrealistic. We don't have 40-foot long studs or 50-foot long studs, anything like that. So we're breaking them up traditionally at the floors, right? The studs, like I said, are usually joined. There's a break at every single floor line, and we don't typically worry about any type of a hinge point or an action point occurring there. And because as the wind moves in and out, we end up having the floor diaphragm that's trying to brace that exterior wall, and that's kind of resisting that movement that you would see like on the left-hand side of the page. So this works with our standard floor construction. But now what if we shift to, say, our shaft wall construction, where we don't have that main floor now that's bracing that joint in our shaft wall, like we see over here on the image on the right. So now we've created this potential hinge, and since there's nothing there to brace that joint at the top and bottom of those studs, what can we do structurally to resist that hinge effect? And so I'll cover just a few of those things in a moment. So before I provide those solutions, I'm going to leave you hanging for a minute before I provide the hinge solutions. Let's take a look at the differences in the 3 different shaft wall types that we have. And at the very beginning, I said that the code provisions for shaft walls really, they apply to all of them, but some of the detailing things that we need to consider might look different. So say for stair shafts, it really comes down to the stair framing itself within that shaft wall. How do we handle those? That's kind of a unique aspect that we need to consider. For elevator shafts, the challenge tends to arise with the ability to support those elevator rails. Those rails do have some significant forces that we must be able to, resist both vertically and laterally. And then for MEP shafts, that really comes down to the actual size of those shafts themselves. So they're often difficult to get into. Number one, they don't usually have some type of a door. Number two, they're very small, and we may need to come up with a way of installing some or kind of all of those shaft walls from the outside without the ability to get inside that shaft. So that creates kind of a challenge as well. How do we handle those? And so let's take a look at our stair shafts. Again, they are unique due to the stair framing themselves. And so this image on the right, we come up, about half the flight of steps, and then we have this intermediate landing. And the question could be, how do we structurally support this landing? How do we support our stringers? We also need to consider the floor joists for the landing itself. Perhaps we can frame those, with some type of a ledger system. Where are we going? So here I'm highlighting kind of this sequencing perspective that shows often how these landings are done. So at this location, they have chosen to install strips of gypsum that allow them to get that landing in place. Then after the fact, they can come back through and install the rest of the gypsum wallboard. Obviously moisture protection is of concern here. So maybe you want to consider using a moisture resistant gypsum rather than your standard type X gypsum at these locations. It's not the perfect sequencing, right? We get it. It's kind of frustrating for the crews to have to come in here and hang gypsum before these landings get built, but it's kind of the beast of the process that we're in with these. If we want to consider kind of an alternative option for that intermediate stair landing, there are a few options. You could install, wood blocking with the wall to achieve kind of that 1 hour fire resistance rating via charring calculations while eliminating a single layer of the gypsum. Or you could eliminate both layers of that gypsum, kind of interrupt that gypsum and install 2 layers of blocking to achieve up to a 2 hour rating. So in doing this, you want to ensure that your ledger is screwed directly into the studs and not into the blocking. And so I think this is a good opportunity if you're considering this, have a talk with the AHJ, see how they feel about this. Basically you're going to interrupt that membrane and you're coming back to them and saying, look, the 2 layers of gypsum were going to give me a 2 hour rating. I want to install 2 layers of sacrificial blocking within that wall cavity where I'm going to be interrupting that gypsum. So the NDS, and I'll jump into that, will allow you to do, basically you get an hour of resistance for an 1.5 inch piece of member of 2x material. So that could be an argument that you present to the building officials or the plans reviewers to see if they'll accept that. So you don't have to go through that, making sure the gypsum is installed first and then all the other sequencing issues. So how would we handle, say, a large beam that needs to extend across our stair shaft and that needs to be supported at some point within that shaft, right? So what are some options for how, we could detail that beam? It's going to be penetrating that wall. One of the options we've used and we've seen used is, like I said, charring calculations, oversize that beam itself for whatever that hourly rating needs to be, whether it's a 1 hour or 2 hour. You can oversize that beam and then you can achieve, you can calculate those charring numbers by chapter 16 of the NDS. I'm happy to walk through those with you. It's not a very lengthy process, a pretty easy calculation to do. Another option you may want to consider would be to create a pocket for that beam. So basically what this does is it creates a protected beam pocket in that shaft wall. So you can see there's 2 layers of 2x blocking that are all around that beam, right? So that gives you the fire protection that you need. You're using kind of, say, sacrificial layers, if you will. So again, getting those 2 hours of protection through 3 inches of sacrificial wood fiber, using charring calculations. So that's an option considered as well. Let's move on to elevator shafts. Remember, we said the unique thing there is that we need to resist those rail forces. And so usually we have multiple vertical rails going up our elevator shafts. And those are really what is conveying that elevator cab up and down the shaft wall. And so because of the weight of the cab, the weight of the occupants, and the way the elevator is being hoisted, that really creates these vertical and horizontal forces, and we must be able to resist those forces. And so how do we do that in a wood frame shaft wall? What are some options or ideas there? So here's a great solution. You can use some kind of a laminated beam, or you can actually just build up some 2x members together, turn them, what you would say maybe in the plank position, and that will give you a continuous surface so you can support those rails, attach those rails, and then basically sandwich those between your wall studs to create a large box section, if you will. That way you have a continuous nailing surface to attach your rails to. This gives you a much larger mounting surface for your elevator rails. The other unique thing with elevators, obviously, is that we must have some type of a hoisting beam in place. This is mostly used during construction. It's also an OSHA requirement to have a hoist beam. It's kind of like your safety device, if you will. Almost all of the time we see hoist beams being structural steel, but that's not something that OSHA or the code actually requires. And so these beams can easily be wood beams if you want to use those. Just ensure that you're consulting with the elevator manufacturer to verify that they can provide details that accommodate a wood elevator hoist beam, and that you're able to obtain the forces that you need to design that hoist beam from the elevator manufacturer. So put that on your engineer's radar as well. Then finally, we talked about shafts, stair shafts, elevator shafts, so mechanical shafts or mechanical and electrical plumbing shafts. Those can be kind of a challenging. Again, the main difference there is their size. They're really small. In fact, you're usually not able to get within that shaft after the fact because there's probably not a door or any large opening. So that's why things like these shaft liner panels, you can use shaft liner panels that we'll talk about today. Those often come into play in terms of allowing us to install those from the outside of the shaft and not having to physically get within that shaft afterwards and do things like taping and mudding the joints and all that fun stuff that there's usually not enough room in there to get to. Earlier, I brought up the possibility of creating a hinge at your exterior shaft wall. One idea to resolve this would be to design your top plates as a beam to handle that out of plane loading. So when designing this, you really must ensure that you do not have any kind of joints or laps in those locations. You want to have a continuous span over that large opening. Looks like I'm getting tight on time here for the amount of slides I have left. So I'm going to try to get through these details very quickly. If you don't want to use the existing plates, you can have your engineer design some type of a beam in there as well to handle that kind of out of plane force. You kind of look at, here's kind of an idea of what that would look like. This is an example photograph. See, they have a very large built up section there. They got a beam that will handle that kind of out of plane load there so that when the wind or there's some type of a seismic event there, it can resolve those forces. All right. Another option to eliminate that potential hinge at the exterior wall would be to just simply ship that plate down to the landing, right? The point there that your engineer needs to be aware of is that, that particular section of your shaft wall, that stud is probably going to be a little bit taller than your other ones because it's going to be a unique length. So making sure they're checking that for the loading requirements as well, because it's going to be longer typically. Now we know that our shaft walls, they can be framed in wood. Let's understand, some of those hourly ratings, continuity requirements, and then let's look at some assembly options that we have here. So we'll go through some of these. I can kind of look over these. There's not a lot to say on these other than if you're looking for, 1 hour, 1 hour double wall or a 1 hour wall with a shaft liner, here are your options available there for you. If you're looking at a 2 hour kind of assembly that you need, here are some options available for you. Hopefully these will be some of the most powerful slides in the whole presentation for you. You can go back and refer to these. Looking at, say, shaft liner systems, they can be typically, they're typically 1 inch in thick. Those are some type of a specialty gypsum product. So if you're looking at 1 hour, it's typically 1 layer of that gypsum product, 2 hours, 2 layers. And then one of the main benefits to using the shaft liner panels is that they can be installed from the non-shaft side. So you don't have to worry about trying to get in that shaft and deal with that. So trying to be aware of my time here. Few examples here that you can kind of see. We have a wood wall that will be bracing that shaft wall system, right? You're going to be bracing those panels back, those studs back at specific intervals, and we'll talk about those. Here's your CH stud option where you can use as a shaft wall panel system as well. And then if you're not familiar with, like, say, bracing requirements, here's just an example where, say, you had a wall that went up to 23 feet and that was the height it's going to go, then you're going to have to clip it off at no more than every 10 feet. And then you kind of move up and follow that requirement. If you're over that 23 feet mark, you're at 44 feet, you're going to clip off it no greater than every 5 feet, and then everything above that 20-foot mark, and so on and so forth as your wall continues to grow larger. There's nothing preventing us from using a mixture of shaft wall. So you could technically have a portion of that being a wood shaft wall on 2 or even 3 sides, and then you can switch to that shaft liner panel on the 4th side of your wall. So you may want to consider this in areas where, it's tight, you don't have an opportunity to get in there. So you can close off that 4th side of the shaft wall. Here's kind of a sketch of what that might look like for you, so that we had the picture, and then we'll complement it with this sketch for you. Pretty nice to go back and take a look at that. And then next we'll review some floor to shaft wall intersection details. And this is where I'll probably kind of jump through these pretty quickly because I want to make sure that we have an opportunity to go through them quickly. Understanding, one of the questions I'll get a lot of time is, when we think about even exterior wall construction of type 3, where you have the 2-hour wall and a 1-hour floor intersecting that, sometimes we'll get the question of, what's the tested intersection look like? And so it's unrealistic to think that industry has gone out and tested every intersection possible. It doesn't exist, right? If we look at, say, platform framing, semi-balloon framing, you think of every iteration of what that intersection could look like, it's just cost prohibitive. Nobody's testing intersections. So what we can do is kind of walk through some of these and give you some ideas. If our fire resistance rating is continuous through the depth of the floor, kind of regardless of whether it's the same wall assembly or 2 different details, if we can demonstrate that that fire resistance rating is continuous to the depth of the floor, then we have continuity. And so one of the things we can look at, I told you chapter 16 of the NDS, that will help us with charring calculations. I can walk through those. I said the nominal rate for charring is 1.5 inches per hour. And so we can basically use sacrificial layers. So if we're using that like blocking or something like that in our wall cavities to show continuity or maintain continuity, working through this. Another great tool, if you're looking at, say, rim boards, there's a report here from Frost Products Lab. It's report 610 that discusses the numerous tests that were conducted on engineered wood rim boards. So that could be a powerful tool for you as well. Light frame wood shaft walls in light frame wood buildings. Remember, we're extending to the underside. And so when we start looking at some of these, there's, like I said, I don't want to take much time to go through every detail in these, but kind of giving you some of the reasoning behind these, right? So we're interrupting that 2-hour membrane, right? And what we're doing is we're installing 2 layers of sacrificial blocking within that wall stud. And so the argument could be made that if a fire was to penetrate that floor cavity, right, we can maintain our 2-hour continuity because we get an hour from each one of those blocking elements. So that way we have that 2-hour continuity. This is a great option here to consider as well. When we have, say, a top chord bearing type situation, we have blocking in between. I actually like the top chord bearing situations. We're going to go ahead and bring that gypsum. We're going to notch it around the top chords. We're going to bring that up through that interstitial space, so that concealed space, if you will, to maintain continuity. So that's an option as well for top chord bearing. You can run a beam that's parallel to the exterior, to the shaft wall there, so that you're not penetrating that at all. Remember, fire barriers, or AKA shaft walls, we have to run that up to the underside of the decking. So we're not doing anything. The decking is not breaking continuity or anything like that. The code tells us that our shaft walls are fire barriers. So we're not doing anything wrong here by running that gypsum all the way up to the underside of the floor sheathing. You're preventing any penetrations in there by running a beam parallel to that wall. Another option that we've seen used are these hanger type systems. We see these a lot in the type 3 exterior wall constructions. They're typically a cost plus item, but there are a lot of teams that have gone to this because the building officials really like this as an option. They're made to go over 2 layers of gypsum and support your floor system. So those are a pretty good option. But once again, there is some type of a cost plus on that. Where are we going here? And then even installing some type of a ledger board over 2 layers of gypsum. Once again, this could become a sequencing issue, getting that gypsum installed ahead of time and then installing the ledger board. The challenge here is making sure that connectors, those screws are designed to, there's going to be a little bit of an eccentricity there because of the gypsum. So making sure those screws can handle the loading. So probably a tighter screw schedule in those locations. And then just some images of your shaft wall, right? We can have your normal light frame wall on the right, wood floor system on the right-hand side, have your shaft liner on the left. You can see the detail on the right here. We have our normal stick-built wall system, and then we're using our shaft liner and bracing it at the specific intervals that chart was telling us about. going back to the manufacturing, getting those interval spacings. And then just some other options where, the shaft wall might not be able to go up. That shaft wall liner is going to have a height limitation. So we might have to figure out a way to support that and kind of start shaft wall 2.0, if you will, shaft wall liner 2.0, installing some type of a piece of angle there to support that to, say, rim members there. That's an option. And then looking at CLT or mass timber shaft walls is an option as well. Super clean. You have fire rated assemblies for 2-hour rated shaft walls, installing a ledger board directly to the CLT and using a hanger system. Pretty straightforward there. Even using, say, a light frame wall adjacent to a CLT wall for your shaft. That's an option as well. Not always do we have platform framing, but there's nothing that states that we can't have platform framing construction. Once again, you're just going to make sure that any opening, you're going to maintain continuity through that interstitial space in the floor system. And then getting into some other materials as I wrap up as quickly as possible here, right? I want to acknowledge that we do have masonry shaft walls that we see from time to time on these light frame buildings. And so some of the things that we need to be aware of, masonry shaft walls tend to become part of their lateral system. We need to be careful with that. We need to understand how that impacts our design, right? Especially in areas where we have high seismic forces. Seismic forces are a function of the mass, and because the response factor for a light frame shear wall is like a 6.5, and for a masonry shaft wall, it's a 2.0. And so we start looking at that, and that really starts to increase our forces. So what we want to make sure is that, if we have the option to use a light frame shaft wall / shear wall, if you need to use that on the project, right, looking at just the mass of these particular types of walls, we're looking at an 8-inch block wall, about 44 pounds per square foot, versus a 2x6 wall that's about 16 pounds per square foot. And so that number, that 6.5 and that 2 that I talked about, that goes when you're calculating your forces, that goes in the denominator, right? So obviously that higher number is going to reduce those forces. And so that can start to create a more robust system and maybe not a path that we want to take. Let's see, there are some restrictions in terms of the special design provisions for wind and seismic. I'll touch on those, where you're not allowed to actually use wood frame shear walls, diaphragms, and wood members to resolve forces due to seismic from masonry or concrete walls. So one of those items to touch on and be aware of. And then last but not least, I'm sorry I had to kind of burn through this pretty quickly at the end, is code provisions. We have another great paper that's on our website, Accommodating Shrinkage for Multi-Story Wood Frame Structures. This is a great complimentary paper to look at here. This is what I'll be speaking on at the AIA convention. And so would love to see you guys there. And so with that, Crystal, please don't be too mad at me. I went to, really at the end of it all here. I do apologize.
No, you're totally fine, Jeff. Thank you so much. We did have one question. I'm not sure if you see it.
Let's see, a request. Is this the one with a request from a contractor in a 2-story townhouse, masonry party
Yes.
wall? Okay, let me look at this one. A request from a contractor in a 2-story townhouse, masonry party wall from foundation to tie beam and second floor ceiling, then fire rated portion above the masonry wall to the underside. Does this violate the continuous requirements? Greg, I think we've chatted before in the past. Do you have a detail on this? I think this would be something for me to take a look at. I need to kind of look at the detail and digest it a little bit here. I don't think that it violates it, but I don't want to be on the spot and say no and then you run with it. I'd like to see a detail of exactly what it looks like. If you can go ahead and send that over to me. Perfect. Thank you, Greg. I appreciate that. I'm ready to make sure that I get you in the good direction here. All right. Well, Crystal, I think that there were no other questions other than Greg being courageous enough to step up and ask that one. That's a really good in-depth question. So I'm looking forward to digging